Hello, chemistry students. Today we are going to talk about two laws, the law of definite proportions and the law of multiple proportions. The law of definite proportions states that in samples of any chemical compound, the masses of the elements are always in the same proportions. And I have this example here so that we can look a little closer. In this reaction, we have magnesium sulfide, which separates into magnesium and sulfur. This reaction happens 3 different times. In the first one, you start with 25 grams of magnesium sulfide, and you yield 10.78 grams of magnesium and 14.22 grams of sulfur. So let's just double check that we didn't lose anything. It's 25.00 grams. So yes, they do add up. And what we have in the last column here is a ratio of magnesium mass to sulfur mass. So for every 0.758 grams of magnesium, there is 1 gram of sulfur. Now this experiment, like I said, is repeated 2 more times with different starting masses, and the results show that the ratio of magnesium mass to sulfur mass is the same in every experiment. So that is saying that in this compound right here, magnesium sulfide, the masses of the elements are always in the same proportions. Now, the next law is the law of multiple proportions, and it states that whenever the same 2 elements form more than one compound, the different masses of one element that combine with the same mass of the other element are in small whole number ratios. So let's break this definition down a little bit for you guys. The first part of the definition says, whenever the same 2 elements form more than one compound. So our example we're going to look into is copper 1 chloride and copper 2 chloride. Both of these compounds are only made out of copper and chlorine. So that is an example of when 2 elements form more than one compound. Okay, so then it says, the different masses of one element that combine with the same mass of the other element. So that's saying if you had a set amount of copper, when you compare the masses of chlorine, the ratio between the 2 chlorine masses will be small whole number ratios. Copper 1 chloride is this green chemical, and copper 2 chloride is this blue one. Okay, so we're going to use green for copper 1 chloride and blue for copper 2 chloride. During this experiment, we took the same mass of copper 1 chloride and copper 2 chloride and split them apart into copper and chlorine and took those masses. So the mass of copper in copper 1 was 64.2, and the mass of copper in copper 2 chloride was 47.2. The mass of chlorine in copper 1 chloride ended up being 35.8 grams, and the mass of chlorine in copper 2 chloride ended up being 52.8 grams. So something to notice right here is in copper 1 chloride, there's more copper by mass than there is chlorine. And in copper 2 chloride, the chlorine has a larger mass than the copper does. In order to find the small whole number ratios of chlorine, what we're going to have to do is set the mass of copper equal to each other. So we want to compare when we have exactly, let's say, 1 gram of copper, how many grams of chlorine do we have for each of these? And the way that we're going to do this is using the ratio on the last column. So that's a ratio of copper to chlorine. Chlorine to copper by mass. So there's 0.56 grams of chlorine for every 1 gram of copper. And in copper 2 chloride, there's 1.12 grams of chlorine for every 1 gram of copper. Now we can do a little bit of math and break that down to a smaller whole number ratio. So the two numbers we're comparing here are 0.56 and 1.12. So we'll take 1.12 grams of chlorine per 1 gram of copper in copper 2 chloride. And let's divide that by 0.56 grams of chlorine per 1 gram of copper in copper 1 chloride. If you divide those numbers, you will get 2/1. So the small whole number ratio between chlorine when compared to the same mass of copper is 2:1. And so that tells you that there are 2 chlorines in copper 2 chloride and 1 chlorine in copper 1 chloride. You knew the whole time that there were 2 chlorines in copper 2 chloride because you know your oxidation numbers and you can see the chemical formula in front of you on this slide, but early scientists did not know these chemical formulas. So a lot of these laws are based off of mass because that is what they had to work with. They would take a sample of something and then mass it and then compare those masses. And what they found after several experiments is that these whole number ratios keep showing up. And that is what helped early scientists discover that atoms always combine in these small whole number ratios.